Hi there, I am Alimul Karim, and in today's session we're going to talk about programming for non-programmers to learn programming from their lifestyle. It's not like we woke up one morning and thought of taking a session for non-programmers. We are analyzing for months to come up with a great recipe for newbies to understand programming out of the box. It turns out some of the programming skills you already know of, but you have no idea that it is programming. So today, we're going to sync those parts with your lifestyle. And in some places, we're going to tell you that how programming can make your life better. I'm going to record this session on behalf of North-South University, which is conducted by Dr. Nova Ahmed. This session is for non-programmers who haven't done any programming before. If you know how to start a computer, Google and copy-paste, then you're fine for the session. However, some of the topics that we're going to cover will also be helpful for programmers who have just started. And by started, I mean 1 month or so. Whatever I say in this session doesn't affect my university reputation. I have a prerequisite for this session. You have to be smart. And by smart, I mean that you Google some of the topics which I do not explain in details. Maybe I give you a keyword and you will search for it. That is smart. And if you can't find it, then email me. I will explain it to you. But you should Google first. So that's the prerequisite. So nowadays, programming is like a must-have skill. So why we're doing this? Over the years, I have seen that many people are afraid of programming. They do have interest, but when they try to learn, they have some fear of programming and they stay away from it. And in this whole session, I will try to tell you that programming is not a rocket science. It's really very easy. It's really easier than physics, chemistry, math, and so on. So what are we going to talk about? Are we going to talk about any particular language syntax? No. Are we going to talk about SEM problems? No, we're not. Are we going to talk about developing something? Well, it's yes, but not in today's session, but we're going toward that. We're going to talk about concepts which sync with all popular programming languages and mostly with your life. That's our primary goal. If you were doing programming for months, then some of the concepts will still help you and try to watch the whole video. If you don't understand some of the things, please email me. I will get back to you. From this whole session, if you get 20% of it, it's just fine because some of the concepts I don't want you to understand at once. You should watch the video again and again and then get it. It's just fine. It's like polishing something. The more you polish, the better it shines. We are going to have 5 sessions of this kind. You will enjoy those sessions online, but join live. It is better where you can ask questions directly and interact with me. So invite your friends and join the group and stay tuned. If you really want to learn, then you need to have some details about the topics. And so we're going to go over the topics in very details rather than escaping some parts. If we escape some parts, then the escape part you have to Google, and sometimes it will take more time to learn than me talking to you directly. So rather than giving you a hint and always suggest you to Google, I'm going to explain many of the things in detail. So this session is going to be very long, but be patient. I will try my best to entertain you. Currently, I am in pursuit of my bachelor's degree at North-South University, which is a great place to learn what you love. Every faculty is very good and very generous. If you really want to get quality education, then I would recommend North-South University. I work for developers organism. We make products for developers, not only for users. We want to do something for the mankind. We have a clear vision and a goal for our future. Currently, we're working on two projects. One is employee tracking system for developers named Developers Connected, and another is Developers Blog, which is an open source ASP.NET blog project, and it is a community project, so if you like, you can join. You might learn something new. So if you want, you can email us info@developers-organism.com. So learning methods. Nowadays, whatever idea you can think of is already exist or someone is already working on it. So while we're analyzing programming concepts with lifestyle, we thought of it would be better if we could show you programming throughout a game rather than coding. So when I first Google, I find an amazing site, code.org, which had excellent ideas to learn programming throughout some small puzzle games. We would have come up with something like that, but it wouldn't be that cool because they have given so much effort in it. However, in these 5 sessions, we will try our best to come up with games like those you'll find in this session. It wouldn't be exact like that, but it will be similar to that. So without further ado, let's move on to our first topic. And the first link is given here. If you want, you can go there, but we'll go step by step. The first thing I would like to point out that math is not programming. Being good at math doesn't make you a great programmer. And the opposite is also true. Being good at programming doesn't make you a good mathematician. Certainly there is maths in programming, but that's not all of it. In our real-world application, we hardly use complex math like sine, cos, theta. Some people love to solve problems in complex way, but it doesn't have to be that way. To influence you towards simplicity, I have 2 quotes. One is from Albert Einstein. If you can't explain it to a 6-year-old, you don't understand it yourself. Another, software engineers spend their first 5 years to make things complicated and then next 2 years to make it simple. Anonymous. Somehow I forget the quote who told me, so if you can find it, mail me. So logic is equivalent to programming. But logic and programming are not equal. So let's say I want to buy cookies and $1 bill can buy 3 cookies. So are those equal? No, these are not equal. These are said to be equivalent. So $1 bill can give you 3 cookies. It means some of the properties of the cookies, in this case the price, is similar to the $1 bill. So where some properties match with some other object, it means those objects are equivalent but not the same thing. Writing a computer program is similar to writing poetry, paragraph, cooking, or driving a car or a bicycle. Certainly cooking and writing poetry are not similar at all. However, some of the properties of those elements sync up. In cooking, you must know your ingredients before doing the cooking. And same is true for programming. You must know what is given. If you don't know what exists in your platform, then you will end up making the same thing, which will be redundant. Advice is to know your tools before using it. If you have an idea in your head, write it down. Because sometime later you're going to forget it anyway. Trust me on this. I have forget many ideas which come to my head, but I haven't wrote it down, so I forgot it. So try to write it down. Don't trust your memory. And that's how I believe programming is similar to poetry or paragraph writing. Time is the most important topic of all. A lot of newbies I have seen over the years tend to switch platforms, and this way they don't learn anything concrete but some basic syntax around every language. So my advice is to stay on a language for 2 to 3 years. You might ask, why that long? I should haven't come to this session. Well, if you think through, and let me take an example to your life, that what you have learned so far. If you take an example of maths, you have spent your 8 or 9 years before running into calculus. You have spent 3 to 4 years on chemistry, and if you think about a second language like as English or maybe French, you might have spent 4 to 5 years on that. So if you think about any concept in your life, you have spent already more than 2 years, but you haven't noticed it or didn't remember it. So 2 to 3 years may seem long, but it's not. So stay on a single platform. So when you gain confidence over it, then switch the platform. That's simple. So anyone can code. Trust me on this. Most of the experienced developer will say the same thing. Analyzing the problem, choosing the tools, what should be appropriate for the problem will be the most important thing than coding. Knowing the syntax, not everything. And it's hardly meant something, because you could Google the syntax and learn it. Coding really comes later, but newbies who are learning at first time somehow have the idea that coding is really hard, but it's not really true. So RAM, this is a very important concept. So whatever you run in your computer first loads into the RAM, which is known as random access memory. So if you buy a computer or bought a computer, then you might have heard that a RAM makes your computer faster because everything that you load or run, it loads up to the memory. So if you have much memory, it will load faster. That's simple. We are not going to go very deep into it. And what is programming? Wikipedia says programming is a set of instructions. So what does it really mean? You can say a single instruction is the atomic part of programming. You can't go any lower than this, a single instruction. So a single instruction is known as a statement. A statement is like a sentence in a paragraph. By combining multiple statements, you can have a meaningful program, like you can have a meaningful paragraph. Whatever you write as a programmer or a developer is known as source code. So your code is source code. That's it. So whatever problem you find in your life or programming can be solved by dividing the problem into smaller pieces. So if you think about a big math problem, how can you solve it? If you really divide it into smaller parts, you'll get addition, subtraction, and multiplication. That's it. And if you solve those addition, subtraction, multiplication, you'll have the solution. And let's say if you are a medical student, you can think of a cancer. So how the cancer is treated or how the vaccination works. So a small part of the disease put into a human body, and that smaller disease is cured by human prevention system. And that prevention system then notify the other part of the body that you can resist that problem. And that's how they solve that bigger problem or bigger disease. But first, you're pushing the smaller disease to the body. So whatever problem you get in a programming section or in your development life, break up to smaller pieces and solve those smaller pieces, and then you will have your bigger solution. So let's say you have your problems and you divided it and you solved it, the smaller problems, and you will have your final solution. So this is known as divide and conquer. This is a concept. So here are some pictures. I always ask people that, do you understand anything from this picture? So most of the time they can, but most of the time they can't. And if I see this, I can't understand it at all. So the concept is you have to see the big picture. It's a shoe. So you have to understand the full picture to solve the full problem. If you have smaller pieces, then you don't know how to solve it. So make sure you have the full picture. So after you have the full picture, let's say you are a business guy and I would like to make shoes in a rapid manner. So what can I do? I separate the parts like as the first part. Maybe it's not like that in business section. It is more separated and more atomic in the business section. But for the simplicity, let's say I part my shoes into this part and then this part and then this part. So one department makes this part, one department makes this part, and one department makes this part. So when they do all those parts, I will have my final result. So this is how you can solve a programming problem. These are just conceptual layers. So if you go to this URL, you'll find hundreds of programming language from the beginning of the history. So you might ask that, isn't there any one programming language? Well, there is, which is called a machine language, but which is really very hard to understand and which is really very hard to write the code in. So we don't write the code in that language. So rather than we write the programs in the language that described in this URL. So most of the language in this URL are known as high-level language. From those hundreds of programming language, there are only dozens or so are popular. And by popular, I mean that they have an open community and they still have current development. And new versions are still releasing so that you could find documentation and upgrade your codes and so on. So by popular programming language, we meant this: C, C++, C Sharp, Java, PHP, Python, Ruby, VB, etc. And whenever I say popular programming language, I really meant those. So programming language like JavaScript, AppleScript, ActionScript, Ruby, Python, PHP, Java, C Sharp, VB, C, C++, etc., and assembly are not really exact machine code, or computer doesn't understand any of those. So here comes a magic or a processing, and after that there comes the machine language, which is known as machine code or binary. So which computer understand? So how computer understand this binary? In computer there are wheres. So in one where, if the electricity passes, computer understand it as 1, and if there is no electricity, then computer understand it as 0. So that's how computer understand your program, and that's how it displays this PowerPoint presentation, and that's how I'm recording this, and that's how everything is done. So this part of the languages are known as high level, and C++ is known as mid level, and this part is known as low level. In most concepts, you will see that high level things are very hard, but in programming, high level means it's easy, and the low level means it's very hard, and the machine language is known as very low level. So the lower you go, the harder it gets. So here is an example, and this is not exact code or any high-level language, but assume that it is. So high-level languages are very easy to understand. So if you see this code, you'll understand that if today is holiday, then it is doing something called vacation. And if it is not a holiday, it is doing something with the office. So in the low level, if it is a program, then computer will have something like 0 and 1, something like that, and which is really hard to understand. You'll see and you'll understand nothing. And this is not the exact representation, but try to assume that this is. So you can understand that how much hard it is to understand. So that's why we use high-level language. So how the high level to low level happens. So to understand that, we have to take a look at real life. So let's say an American guy tries to say something to a Chinese guy. So let's say in this case, the Chinese guy doesn't know English. So American guy says, "Hi, how are you?" So Chinese guy is like, what he's saying? I don't understand. So he can't communicate with the American guy. So what happens in real life that the real life interpreter comes in. So an interpreter is someone who knows both language in full form. So when the American guy says, "Hi, how are you?" So then the interpreter says the same thing in Chinese to the Chinese guy, and then the Chinese guy understands it. And when the Chinese guy says something to the interpreter, he interpret it in English and say to the American guy. So that's how they talk. So in programming, nothing is different. So there are two concepts. One is called interpreter and another is called compiler. So let's say you write your code. So whatever machine you write your code is known as development machine. So let's say you write your code, and if it is an interpreter, you have to give your source code to the production machine. That means the client machine that they're using the code or using the program. So there's something interpreting, or you could assume that there's some magic happening going on, and they will get the machine code, and in the display it says that I am running. That's simple. So why I'm saying about interpreter, because all the browser like Google Chrome, Opera, Safari, Firefox, IE, all are interpreters, and FlashShare and Java Virtual Machine and so on. And if your program is interpreter based, then you have to give your source code most of the time, but there are different scenarios. You don't have to understand it more than that. You just have to understand the concept. That's it. So what is compiler? Compiler is similar to interpreter, but there are some differences. So let's say the development machine, you write the code and you compile it. So after the magic or the compilation, you'll have the machine code, which is known as application file or exe file or executable file. So when you give the executable file to the user, it will run directly without any compiler or any source code. So it's really very handy. But for the compiler, if it is made for a single platform like Windows, then it won't run on Mac or Linux. So sometimes when you compile, there is a mid-level code which is known as object code, which does not in the exact machine code or 0 and 1 form. So when you have an object code, then an interpreter comes in or a linker comes in, and then the linker or the um, interpreter runs the code again and gives the output to the user. So now we are going to talk about fundamentals of programming or programming 101. So now let's take a look at how all the programming languages are synced up. So we're going to talk about this concept step by step. So let's see. So first, case sensitivity. It's a very important concept. So let's say I write hello and then hello, and everything is hello, but the letters are different, as you can see. So first, this letter, which is in smaller case, known as lowercase. So character which is not in capital form is known as lowercase. So a character which is in capital form is known as uppercase. So when it is mean that case sensitive, you have to match the cases. So in this case, the H and H match, but E does not match. So in this case, if you match with this hello and this hello, this O and this O doesn't match. So these are not equal. And same is true for that. So when it is case sensitive, you have to check all the cases. So most of the programming languages, popular programming languages, are case sensitive. So when they're case sensitive, you have to be sincere about the cases. You cannot write one place in uppercase and one place in a smaller case. You have to be sensitive about it. So some languages are non-case sensitive. So non-case sensitive means that all hellos are equal. So we don't check the cases. That's it. So space and new line, in most popular languages, space and new line doesn't matter, but some language it does matter, but we're not going to talk about it. But for simplicity, you can remember that space and new lines does not matter in programming. That's simple. So brackets and closing. So let's say we have a parenthesis, which is an opening parenthesis, and if we have an opening parenthesis, we must have to close it with other parentheses. So same is true also for curly brace. If you have a curly brace, then close it. If you have a square bracket, close it. If you have an angle bracket, close it. So if you have a block of code and middle, if you have other codes and statements, then you also have to close that block of code with your appropriate syntax. And this is a very important concept for newbies. So I have seen many newbies, they tend to forget the parentheses. When they start one, they forget to give the closing one. They start the curly brace and they forget to end the curly brace. So don't do that. If you ever start any one of those, you have to end it. You have to remember that. It's a very important concept. It's a very easy one, but don't forget it. A variable is a symbolic representation of a value or an object. A variable means that it could hold any type of object or any type of value. That's it. So signing. You could assign a value to a variable. So in most popular programming languages, equal means signing. So if you say x equals 5, that means you are signing x variable to value of 5. That's simple. But there are some differences, math versus programming, assigning. So in maths, if you're doing a math and if you say 75 equals x, then your teacher or instructor will understand that you're saying that x equals 75. Or maybe you try to say that x equals y and you're writing y equals x. And maybe you want to say that z equals x or maybe y equals to z, something like that. So when your teacher sees it, if it is sequential math, they will understand or assume that you're correct, if you're logically correct going through. But for programming, there is only one way. For programming, always left side equals to your right side value. So let me show you what it means. So if I want to write x equals 75, so I cannot write that 75 equals x. I have to write x equals 75. So if I mean that x equals y, I have to write x equals to y. I couldn't go y equals x. It would be a different thing. And if I want to write the last statement, I have to write it like this, that I meant that x equals z and y equals to x. I cannot write whole thing at once. But maybe some programming, because there are hundreds of programming languages, maybe some does accept that, but I don't know of. But in most cases, you have to do like this. That's simple. So let's say you have a variable called pic. You could hold a picture to the variable. And in this case, we have a picture of Java. And sometimes you could have a data type in some programming language. In most programming language, you will have data type. And your data type could be any object. And in this case, we have a custom object called picture, and that could hold a picture. That's it. So you write, first you write the, So first you write the data type, and then you write the variable name. And then you assign the value to the variable. That's simple. So let's say I have a variable called I, which is a data type of int, means integer, which will not take any fraction of numbers. So I'm assigning it to 500. So that means the value of I will be 500. So again, I could change the value of I. I could say I equals 200. And if you take a look at previous example, which we done with the picture, which is same, but we could also change the value of picture to anything else. We're going to spend a little bit more time on function because function is the key point in every programming language. For every program, there is a starting point, and most of the time, that starting point is with your main function. So in most popular programming language like Java, C, C++, C Sharp, or VB, and so on, you will have a main method or a function which is your starting point. And from that starting point, you could visit other functions, and again, eventually you'll come to the main function and end the program. It may sound boring, and if you're listening it for first time, you're going to forget it. Forgetting is fine. Come back again and watch the video. It will be helpful. So why use functions? In simple words, functions will make your life easier. So let's say a coffee maker is a function. A function could have some parameters, could have one or more parameters, or sometimes could have no parameter at all. In this case, we are passing the parameters water, coffee beans, sugar, coffee maker, or milk. And then maybe there is something crazy happen inside the coffee maker, and then we get our final output, which is coffee. And we're pleased with that. And that's function. A function is like a black box that something happens inside the hidden or the abstract layer, and you don't understand, and you don't have to understand it at all. And these are some complex examples of functions, and these cell phones may look different, but under the hood, some of the things are really same, like the cellular capacity or the keyboard or something like that, and which are really maybe manufactured from one machine by giving different parameters. So these are the concepts of functions. So let's take a look at programming, what functions do. So in most popular programming, if you see two parentheses, one is opening and one is closing, you have to understand that it's function. In most cases, in most programming languages, it's function. That's it. And function is a concept that you already know of, but you don't know that it's programming. So in your high school, you have done math functions. And if we take a look at this fx function, where x is the parameter or the variable of the function, and if we pass or replace the x with 2, then all the x inside the function will be changed. And the value for 2 will get 13, output result. So if we pass 10, we'll get 125. That's simple. So if the parameters is 2, we'll get the outputs for different parameter inputs. So you can see that rest of the variables or constants remain intact. So here square and this 2 and this 5 remain constant, but rest of the parameters are changing. So same is also true for programming functions. So let's take a look at programming functions. So if you try to make an addition function, so we could write function and the function name. In this case, we're saying that f is the function, and we're taking two parameters, x and y, and inside we're saying that return x plus y. So which will addition those x and y and give us the results. So how can we use it? We just say var x equals to f and pass 5 and 3, and it will add those numbers and give you a result to x. That's simple. So that's how you can write a function. So it's JavaScript, and you can also use it in ActionScript as well. So some of the functions in other language. So JavaScript, it's really very simple, as we can see, and it's not a good pattern, and we'll see the good patterns in later lessons. But for now, simplicity, that's how it works. So if you are in C, C++, or Java, you may have a data type and then the function name, and for each parameter you will also have a data type, and these data types are going to be replaced with your actual data type. And there is a return data type returns, so it means that whatever data type you given here, the data that passed will be in same data type. So it will be more clear when we get to the functions in real programming. But for now, if you understand it, or if you don't understand it, just go through. It will be just fine. So VB or VB6, you could write like this, but we're not interested in the syntax, so we move on. And writing a function isn't hard, and you should able to write functions. And even though we have talked about that, when you're using a function, you just think at is as black box, that you don't see what is inside going on, and you just use it. But in most cases, you need the specific functions or specific things to do, so you have to write your own functions. And it's not very hard. If you can write a single line of code, you can write a function, and we'll see the function in our later sessions. So why write a function? We talked about it, and now we're going to see some examples of programming in learn.code.org. So let me switch over to the browser. So here I'm in the browser learn.code.org. So here I have tested some of the puzzles because I really liked it. So let me start from the stage 2, or you could visit the URL which is given in the slide, hawk/1. That's it. Okay, so there will be some videos and examples that how you can do it, and whatever you place in this white section are going to be interpreted as code in the code section. So as you can see that move forward is a function. So we're just placing those, and it will work just as writing the code. Simple as that. So here, each block takes each forward steps. So here, to reach that cartoon character, we have to go 2 steps. So I write 2 move forward action. So if I run my code, my Angry Bird will hit that. And if I continue, I will have my next problem. So in this problem, I have to go 1, 2, 3 steps forward. So just put those 3. So you're writing 3 lines of code, 3 blocks of code. If you just see the code is just move forward, move forward, move forward. That's it. So run the code. And puzzle 3. So here, as you can see that I have to go 1 step forward, 1 step forward, then I have to go down. So for down, we could use the left word, because I have seen that from the down, it takes the right toward this. So if it is left, then we will go like this word. So let's see how it works. So I missed it. 1, 2, move, move. So it may be left or right because it's really hard to say. So let's run the program. Okay, so I did it wrong. So I have to use the right. Okay. So we have to go from here, here to here, and then here, then here. So first we have to move forward, and then we will be here, and then we have to turn right if the icon is right. So left, and then we have to go one step forward, and then we have to go one step left again, and then one step forward again. So if you see the code, we just calling the function turn left, move forward, turn left, move forward, something like that. So if I run the code, see that each code is running, and you'll see. Okay, so I made another mistake, so it should be right. So I messed up with the right and left. So continue. So here I have to first go right because my Angry Bird is facing toward this TNT box, and I shouldn't have hit this. So I have to move right, which will be maybe this direction, and then I have to forward one step, and then I have to really make it left again to showing this direction, and then move forward. Then we'll be here, and then forward will be here, and then maybe again forward will be here, and then we'll have to move left and then forward. So if you see the code, it's just turn right, move left, and so on. We're just calling them functions. That's it. So if you run the code, see that the Angry Bird is moving. That's it. So we've done the basic functions stuff. So let's move on to other concepts in programming. Let's take an example of this add function. So here, uh, after the return x plus y, we have a semicolon. So if you see a semicolon after end of a statement, you have to understand that it's a C-based syntax. So this programming language is somehow following C's syntax, but it's not exactly same as C programming language. So this exact syntax or same code will also run exactly same in Java, C, C++, C Sharp, and so on. But it really doesn't mean that these all languages are identical. So same syntax doesn't mean that languages are identical. So here, as you can also see, that I have a curly brace and I have ended with one. So you have to be careful with those. So now we're going to see some loops, and loops are supported in almost all programming languages, and some of the common ones are for while, which supported in all programming language, and for is supported in few programming languages. So let me go over this very quick. So loops are invented for doing repeated tasks. So let's say in real life example, you have school life, college life, daily job, making tea, taking classes, and again. You're doing the same thing again and again. So if I really say that if you could escape those boring parts of your life after doing once, you are like, hoorah, it's really awesome. But it's not really possible in real life. But you can do it in programming. So let's take an example. So if you remember our coffee example, coffee maker example. So let's say we have our coffee maker and we want 50 cups of coffees. So what we have to do is we have to pass the parameters again and again 50 times and get the coffee. So we pass water, sugar, coffee beans and get a coffee, and then again. So we're doing it and we just get bored, and I need a coffee. I need 50 cup of coffee right now. So you need a loop. A loop can change your life. So a loop, and for now, for this topic, we're going to talk about for loop, which is very important and supported in almost all programming languages. So a for loop has mostly three parts. One is starting, one is condition or expression to stop the loop, and another is how to increment or how to decrement, or how many steps to take the increment or decrement, you can say it. So it's something like this. You write for, and in the first case you write the starting, that where to start from, and in the middle you write when to stop, and at the last you say that how to increment or how to decrement. And inside the loop you'll do some which will be repeated for the condition that you have given, and it will increment the times that you have given in the increment section. So it will be more clear when we see it in action. Don't worry about it. So we do some work inside the loop, and we end the loop. So every programming language, the loop syntax might be different. So you will use that beginning and ending syntax for that loop, for that specific programming language. So for this purpose, we could use that starting from 1, and when the number of the coffee is less than or equal to 50, and increment the step by 1, because each time we need 1 coffee, but if we need 25 of coffee, we could increment this condition by 2, or we could write increment by 1 here, and here we could write that 25. So either way, you could have 25 cup of coffee if you change the increments or the conditions to stop. So after repeating this loop 50 times, the computer or the program will be stopped, and you will have 50 cup of coffees without writing 50 lines of code. You'll just write 1 line of code. That's it. So let's take an example of loops in the website. So here I am in the learn.code.org hawk/6. So here we have a looping problem. So we can go to that icon by going 1, 2, 3, 4, 5 step by writing the 5 forward command, calling the forward method in this case. So if it is 5, then run the code. You'll go to that icon. But we have to use, but we are not doing it efficiently. We're really doing it dumbily. So how can we do it smartly? We could use the loops. So in this case, we're using the loop since we have to go from 1, 2, 3, 4, 5. So we say here, repeat 5 times and just say move forward. That's it. So if you see the code, it's starting from 0. Here in the slide we started from 1, and they are starting from 0, and that's why they are going from 0 to 4, as you can see that 0 to 4. So 0 to 4 will give you 5 times loop, and count plus plus means increment the count by 1. Okay, and inside the loop we're calling the function. That's it. So if we run the program, our Angry Bird will loop through and go to that icon. That's it. So continue. So here the problem is it's looking toward this direction. So we have to change the direction by using a right, turn right. So if I am good with the right and left, it will work just fine. So how many times I have to go through? 1, 2, 3, 4, 5. So I have to give the repeat 5 intact. So if I just put the move forward. So if I want to move, let's say 10 times and write 10, and if we see show code, you can see that it is starting from 0 and it's saying that stops at 9. So we are saying that count is less than 10, which means it will not increment after 9. And count is every time increment by 1. So as you can see that it's very straightforward code, and so far you have all the knowledge to understand this code. So we are doing the code by this game, which is very friendly. And we just run the code. You can see that our Angry Bird is going to that icon. Okay, so again, now we have the direction change problem. So we have to change the direction. So we need to have 2 loops at least. So 1, 2, 3, 4. So first one should be 4 times. So I have to go 4 times forward. It is in this direction, so it's fine. So again, we have to move left, as you can guess. So if we just put it with this, then we're here, so we have to go this 1, 2, 3, 4, 5. So 5 is fine. Repeat 5 times forward. If we see the code, you can see that there are 2 loops. One loop is running for 4 times, 0 to 4, and another is running for 5 times, so again 0 to 5. That's simple. So if we run our program, as you can see that when it is running, it's really yellowish. So we're done. So here we have a given loop, so we have to use that loop and solve our problem. So for this problem, we have to come up with a pattern to solve a problem with only this 3 times loop. We cannot use other loops, but if we want to use other loops, we still can, and we are going to do it at first. So how to remove this loop? You cannot remove this loop because it says here that you cannot remove gray loops or gray things, gray boxes in this white space. So to do this, what I can do is move it left and move it then right. So if you go move left and right 3 times, it will be in the same place. So if you're going 1 time left, 1 time right, you'll be in the same place, but you cannot do with the forward. So if you put forward here, we'll have a problem. So let's say, so for first thing, we have to go 1, 2 steps. So forward, 2 steps, and then 2, we have to go 1, 2, and then we have to move right. So right, this one. So after that, when we are right, so we need another loop, and this time we have to go 1, 2 times. This one. So again, we have to move right maybe. So right, and then we have to go 1, 2 times. So 2. So forward. So if we run our program, so it will be in the same place. So the loops are removed, and we'll have our exact result that we want, but it is not really efficient. So now we're going to now we try to have the pattern. So if we have a programming problem like that, so where you have to find a pattern, you have to spend some little bit more time to find the pattern. So here, if you see that first condition that you have to fulfill, which is forward, and then you have to move it in this direction. For this direction, you have to go at least right once. So let's really do the first things first, because you at least have to go in this direction. Otherwise, it won't work. So if you just put 1 forward and 1 left, so it will go to this direction and move to right and try to go this direction, it will fail. So you at least have to have 2 forwards and 1 right. for the first condition. And if you go through for the second condition, so when the loop runs again, so when it runs again, it will come to here again, and then here, and again move to right, which will be in this place, and it will again go to 2 steps forward. So it will be done, and we have here 4x4 code blocks. So if you just see the code, it's very simple. It's running 3 times, and inside we have these 3 functions calling. That's it. So if you run the code now, we'll have our solution. That's it. So anyway, in programming, you could solve a problem in many different ways. So this is called repeat until block. So in previous problem, we have given the numbers, but here we don't have to give any numbers. It's like a while loop, and we'll see it in this section. So let me go over to the slides. So here I am. So you could also, here is a syntax for a single loop. If you're running the loop for 51 times, it will run for 51 times. Since we're starting from 0 and running for 50, so 1 to 50 is 50 times. So since we're starting from 0, so it will be 51 times. So this is really wrong. It should be 51. Should be 51. 51. And for incrementing, we're saying that I plus plus. So I plus plus actually means that I equals to I plus 1. That's it. So whatever value I has, I will be increment by 1. That's mean by I plus plus. So as you can see that we have a semicolon at the end of the syntax statement. So that means it's C based, and it's actually compatible with C, C++, Java, or C#. So you have to be careful with those parentheses. So if you really miss those parentheses, your program will not run. So inside the conditions, in the first pseudocode, we have seen with the commas, but in actual code like PHP, C# or C++, you have to use semicolon. Okay, so here we are decrementing. Minus minus means decrementing. Whatever value it has, it will be decremented by 1. So I minus minus means I equals to I minus 1. That's it. Starting, ending, starting, condition, and decrementing. So that's it. So in JavaScript, you could also write like this, or in previous programs, you could also write like this. Both are same thing. So we have seen examples of loop. So let's see the example of while. So while means you have to give a condition here. So whatever condition you give, if it is true, then the while loop will run. So when the condition is false, the while loop or the statements inside the while loop will not run. So if the condition is true, it will run. So we also have a do-while loop in many programming language. We really don't use it most of the time, but it's sometimes it is efficient to use it. So do-while is a different concept. To explain it, I really assume that the image will do a very good job. So do-while does it, whatever you give inside the code, it's really write like this. So you write do and use the curly brace and write some syntax inside, and at the end you will write while, and inside the while there will be a condition. So whatever you write in the condition, it will run at once. So as you can see that we are going once, but if the condition is true, then we are going back again to the loop block. So this is the block. So if the condition in while is true later, we'll come to the block. But if it is not true, then we'll just go out. But do while and while difference is do while will always run at once, but while will only run if you have the condition true. That's it. So let's take an example of while loops in the web. So as you can see, here is a while loop which says not finished. So until it's finished, until it meets its condition. So not finished, so it means that it's true, it's not finished. And then whatever you write inside, it will run. So if we just say forward, so since it is in the same direction with this icon, so if we just go to the code, so that means that if it is not finished, do whatever inside the curly braces. So in the curly braces, we're saying that move forward. So move forward until it's finished. That's it. So if we run our code, okay, that's it. So again, take it. So we just call move forward, it will go forward and again forward. Again, then we have to move uh, forward and then we have to move left. So it's really like the previous problem we solved with the for loop, but here we are doing it at with while loop, and every while loop can be translated into for loop, and every for loop can be translated into while loop. So it's just the developer's preferences, but most of the time we only use the for loop. So if you understand the for loop, that's it. You don't have to really go through while loop as well, but it is also widely used, so you can take a look. But if you understand for loop, it's fine for you right now. So again, we have a while loop and we have a zombie here. And from if you want to go from the downside to upside, you have to understand that these are the lefts. These angles are the lefts. So first I have to go forward for this step because it's in this direction. Again, I have to move left, so left, and then I have to go again uh, forward, forward, and then again I have to go in this direction, so which is going to be uh, the left again. So this is left, and this should be also, this is left, so left, this should be right maybe. So let's see. Okay, so yeah, it's fine. So after giving the loop, we just sit back and watch the zombie to eat the flower. That's simple. So again, we have a same type of problem. So here we are just saying forward. Oh, sorry, we can't say forward because it's looking in this direction. So there is a flower which could eat my zombie. So I have to go in this direction. So I have to go left. And these left and rights are really very tricky. From these directions to go to left is really in this direction. So you'll be confused with this left and right, but don't be. Just change the left and right if you see that you're not doing it right. And again, after that, we have to go in this right direction maybe. So let's give it a try, right direction, and then we have to move again to this forward. So forward and run the program. So we did it wrong. So it's really very easy. So whatever we choose left is going to be right. Right is going to be left. So that's it. That's it. So here we have if block, which is a condition. So we're not done yet with the conditions. So let's see the conditions in our slides. So conditions, which is also supported by every programming language. So if else are common, and some programming language have switch and some have select, but they both do the same thing, and some really don't have switch or switch or select. So if or else is common in all programming language, but we are going to see all of those in very short time. So let's take a scenario example or real life example that your boss says that you should take the deal if they offer 5 million or more in cash. So if they don't take the deal. That's simple. So if they do, then take the deal. That's simple. So you take the deal. So that's how the conditions are applied in real life, and in programming it's not that different. You just write the if, and then you write the condition or the expression, and then whatever you write in the condition, it's evaluated to true or false. And in programming, whenever a thing is converted to true or false, we say it a Boolean. Boolean means a value should be true or false. So it's a data type. It's common in most programming language. So let's take some example of conditions. So let's say you say that 6 is greater than 5. You're saying that. So whenever you say that, it's really evaluated to true or false. In this case, it will be true. So again, whatever you say will be compared again with computers true or false. So whatever you say is going to be again checked that if it is true, then the if conditions or if statement inside the statements of loop will be run. So let's take another example. So x is greater than 5. So if that is true or false, so if x has a value of 9, then this condition will be false, and it will be compared with again true. So false, if the false is compared with the true, it will be return false. So if true is compared with true, it will return true. So if it is x is 9, it will return false. So if it is 11, say, the whole thing in the condition will return true, or your if condition will run. That's simple. So if you have x is greater than, you could say like that. In maths, you just say greater than, and in the below you just give the equal sign. But in most programming language, you use first greater than and then equal. Equal sign will always be in the right side. So if you want to say greater than equal, you put the greater than sign and then say equal. So if you want to say less than equal, you put the less than sign and then say equal. So it's like this. So these are known as relational operators. Greater than, less than equal, greater than equal, something like that. So it will be evaluated as previous, and if it is true, then the condition will be run. So you could also say like this, that x like this, that in both ways, like 10 is greater than x. So it's actually this previous condition. We just write in this form, and it's also acceptable in conditions. And if it is true, then your code will run. That's simple. So let's say you say that 10 is greater than x, which is equals to true. So you're saying this, the whole part, and your computer will then evaluate the whole part as true or false. So it first, what it will do is it will evaluate this part. If this part is true, then it will compare with your true, and finally it will also compare with computer conditions true. So actually you can say equals true, but computer will always do it for you, so you don't have to say that 10 is greater than equal x, which is equals to true. You don't have to say that because it will be also done implicitly by computer. So you can say that, but it is not necessary. So that was an example. So we could also write like and. So and means that when both parts are true. So it means that we're saying that when x is greater than or equals to 10 and less than and equals to 20. So we are giving a boundary to the x. So x number must be in 10 and 20. So you could say 15 and the condition will be true. If you say 25, the condition will be false. So as simple as it. So it will evaluate both of the part and then join those both part and compare those. If both are true, then your condition will be evaluated. That's simple. So when you use and, it means all of those have to be true. You can use another and to join another condition as well. You could write another condition. So which will be eventually evaluated to true or false. And you could also write like or. So or. So when you say or, it means this one true or this one's true. So any one of those are true, the condition will be evaluated. But in the previous case, we have to also go through, let's say, 10 and 20. But in this case, if the number, maybe we cannot give an example, but or means that if any of the part is true, the condition will be true. That's simple. If any of the condition is true, the whole condition will be true. That's simple. So if part means that if the condition is true, whatever I'm showing in previous, so whatever you write is actually evaluated to true or false. So if it is true, then whatever you write inside the if block will run. So whatever statements you write will run. So for every if statement in every programming language, there is a end condition syntax, so you have to find it. For C, it's really the curly brace, that's it. But like VB, it is end if, but we're not interested in the syntax. You could search the syntax and learn it. It's really very easy, but the concept is different. Concept is main thing here. So if you don't understand how and or works, you will be in trouble. So you could also use else part. Else part means that if this part is not true, then this part will be executed. So whatever you write, this part will be executed. So you could have multiple lines of else, if, else if, and else. So else if means if this condition is if previous condition is not true, then if this condition is true, then this code will execute it. So, and again, if else if means if that previous condition is not true, then this one will be executed if this one is true. And else part means that if none of those are true, then else part will execute it at any point. So else means default. So if none of the above is happened, so else part will execute it. So if any of those happen, then that will be executed. So if means that the conditions will, if you have a if block like this, that if condition, else if condition. So if you have a block like this, the concept is the compiler or your program machine code or interpreter will go once through the loop. So if you have any of the conditions true, it will not run the other conditions. Only one condition will run from a if block. So if you have this type of multiple blocks, only one of those will be run. So if else part is run, the others will not run. So if this part is run, the others will not run. So if you have multiple of if, so let's say I have a if condition here, and then I have end if here, and then again I write if here. So it means if this condition is true, then this will be executed, and if this condition is true, this will be executed, and both could be executed. If both conditions are true, both could be executed. But in this case, if this condition is true and this condition is true, they both will not run. Only one of those will run. which comes first will run, and the rest will not run. So this is the concept. And everything you write inside if block is known as block of code. So you could have nested loops. You could have nested you could have nested complex conditions with if. So as you can see that we have a first if, then inside second if, third if, fourth if. So inside the fourth if, we have some conditions and statements. So if that fourth condition is true, this one will be executed, or else this will be executed. And if none of those, so after that if fourth if block, whatever code's inside the third condition, so third condition will run here, and if the third condition is false, then these codes will be run. So if the third condition is false, the fourth if will never run. So this is the concept. So you have to int all the ifs. So if you don't int, you will have a bug in your program. So it will be a compilation error, known as compilation error. So let's see some of those in our web. I'm here in the learn.code.org/hawk/14 example, which we were previously, and the gray boxes are bound to be solved as it is. You cannot change it, or you cannot remove it. So as you can see that here are multiple blocks of code. So here is a nesting codes. As you can see that if nested in the slide. So if we see the code, you can see that here is a while loop, and inside we have a function, and inside we have a if statement. So if a statement is currently saying that if the path is left, then do something. So inside something we have nothing. So first we have to check that if we don't have a forward, we cannot move. So we have to place the forward, and then we so forward is already given here. So if the path is left, as you can see that there is a left. If there is a left, then go left. That's simple. So if you see the code again, so if the path is left, then go left, turn left, and you have to move forward. So it will forward, but when it is have a path to left, just turn left. That's simple. So if we run our program, as you can see that it's always checking that if it has a path to left. So if it doesn't, it's just going forward. That's it. Okay, so here we have another problem. So here we have to move forward a list. So repeat until we have to put it. So forward first, go forward. So here we could use a if statement. So if there is a right turn, so assume that this is a right. If it is not right, then we will change it. So if it is right, then go right. That's simple. So go forward. If there is a right, go right. And if there is a right, go right. That's simple. So let's run our code. Yes, it's always checking the right. As you can see that it's always checking the right. And if there is no right, it just goes. So we can solve the problem in different ways. So if we just go to our previous problem, we could solve our problem differently. So we could do like this. If there is a forward, ahead means if there is a forward, then go forward. So if there is no forward, then check again. So if there is no forward, right, check go right. Sorry, so go right. Will also work, but it will take some more lines of code. So if you see the code, if there is a forward path, then take the forward path. If there is a right path, then take the right path. That's it. So if we run the code, we'll have also exact result, but this time we're checking in both directions. So it's really costly, but it's also more logical. So we move on to the next problem. So here you can also solve it as previously. So we could use our for if condition, and if there is a header path, then move forward. So if there is a left path, then go left. That's simple. So if you run our code, it will check both direction. As you can see that both direction it's checking all the time. So if there is a path to forward, it takes it. So if there is a path to left, it takes it. That's simple. So we could minimize it to 4 blocks of code by doing our first example. We have to go forward. So we're going forward. So if we have a path to left, then we are taking left. That's it. So if we run our code again, see that it's always checking the left this time only, but not checking the forward. It's just going forward. So if there is a left, take the left. That's it. So if you see the previous code, so put there. See the code? That's straightforward. So move forward, if left, turn left. That's it. So here I have to again use the previous example. Move forward. If there is any right, maybe, yeah. Take the right. That's it. But you could solve this type of problems any way that you want. So as I've said in the first topics, that programming is actually logic, and in these problems you are actually using your logic to solve the problem. So here we have also if-else block. So as you have seen in the slides, that if-else means if the first part is not true, the else part will run. So if we just use inside a for loop, so I'm going to go over as dumbly as possible. So if we have a forward path, take it. If we don't have a forward path, use the left. Okay, so you see the code. If there is a forward path, take it. Else, take left, right, left. So if it is not a forward path, then always take left. So if we run it, since you can see that there is also a left path, but since it is taking the forward path, the left part is not running. So on a if block, one condition will run, but if you have multiple of if blocks, then both of them could run. But in a if-else block, only one of those will run. This is very important. So here we could solve it like previously, move forward. So if we have a problem, we could go right. Yeah, if we don't have a forward, then go right. That's it. Yeah, simple. So this one is very good example of nested coding. So as you can see that you could nest as much as you want. So you could have a loop inside, you could have an if-else loop, and inside that if-else you could have another if-else. Inside that if-else you could have another, and inside you could have another, and inside you could also have a for loop, and inside that for loop you could also have a if-else, and inside that if-else you could also have a for loop. So you could nest as much as you want. There is no problem with it. So if we see the code, you can see that you have nested so many times. So it's just simple. So whatever you nest, you must close it with your closing condition. So in this case, the curly brace is our closing syntax. So we're going to remove it. So if we have a head, take a head. If we have a right, take the right. If we don't have a right, take the left. That's it. So you see the code. So if we have a forward path, go forward. Else, if there is a right path, go right. If it's not a right path, then go left. That's it. Run the program. As you can see that when there is a forward path, it's just taking it. And when it is running, the color is becoming yellow. By this logic, you can also program a robot to go to any direction that it wants. So simple. So we're done with 20 problems, the first 20 problems, basic ones, and we're done from done for the slide. And let me go over to the slide again. So now we're going to go over the switch or select statement. So some programming language it's called switch, some it's called select case or switch case. So what happens is you give a value of an object, and each time you write case and then write the condition for that, and the condition is always going to be equal condition. In the if, you have seen that you could write less than equal, something like that. But here in switch condition, you always have one choice, which is the equal condition. So whatever you write, so if it is x, if you write 5, that means x is checking with if it is 5 or not. So if it is 5, these codes that you write inside will run. So some programming language needs a break statement, which means that after doing these things, break from the switch. And some programming language doesn't need the break statement like VB, but all the others like C#, PHP, JavaScript all need the break statements. So we could have multiple cases, and it's really cleaner than if a statement. So when you are checking one variable with multiple cases, switch is better than if. But when you have multiple conditions with multiple variables, if is always the better one. So some programming language also have a default case. So in the default case, if none of the above is happen, then the default case will run. So in some programming language like C, C++, Java, or PHP or JavaScript could run all the case statements if we don't break things up. So if you don't use the break statement in C, what will happen is if this condition is true, it will run after that. So this will also run if you don't use the break statement. So remember that. It's a very important concept. So let me take a look at numbers. So if we pass the x as a variable, so we are comparing x with the 5. We're saying x equals 5. So if x equals 5, then these things will happen. And if it is a C-based language, if it requires a break, then break it, or else if it is equals to 5, it will also run these statements as well. So you will be confused. So use the break if you have a break statement, or if your switch case requires a break statement. So naming convention. So I have seen in many beginners, and I have did it when I learned the programming, that try to name all the variables with X, Y, Z, and something like that, with the single character or in the shortest way possible. But don't do that. Try to name your variables appropriately. There are some naming conventions for the specific language that you are coding in. Scope or blocks means it represents a variable life cycle. So in previous sections you have seen variables. So life cycle means that when a variable is going to be expired or when a variable doesn't work anymore. So it's also known as life cycle concept. And if you can find out the blocks in most programming language, variable is uh, live inside one block of code. So if you go from one block to another, the variable is expired. So will not, or you can say that it is not available in that life cycle. So here is an if statement. So as you can see that I have boxed out. So each of the boxes are the blocks of code. So whatever variable you declare inside those boxes will be stay inside those boxes. So you cannot call that variable outside of that box. So you have to understand that concept. It's very simple, but if you don't understand, email me. I'll give you more examples of it. So it's a video, so you can go back and see the blocks again. So here I have two functions. One is do, another is do2, and the third function is function. So the third function takes two parameters. One is param1 and param2. So from this do function, I am calling this function. This function is called from this do function. So let me introduce some variables. So let's say that these are the block of codes since I'm decorating with the box, but it's mostly true for all the programming language you are going to encounter. So it's very important concept. If you understand this, most beginners suffer for this months. So it's a very important concept. If you understand this, 70% of the programming is done. So let's say we introduce a variable or declare a variable x as int or data type, x and z, two variables. So x is 50, z is 20, and in this function we are also going to declare x equals to 20 and y equals to 30. And I have pointed out this x and this x because these two x does not make any sense. These two x's are two different things. It's like it's in Bangladesh and it's in India. So in two different countries. So they don't mean the same thing. So if you're confused with it, it's possible that someone haven't explained you. So if you understand it, 70% of the programming will be done. So again, if I declare a y here, y equals to 200, since I haven't declared any y here, but since we're calling the function function, which is this, but it also have y, but as you can see that it's inside a block, so a variable will remain available inside a block. So it is available inside that block. So if you replace that block, total block here, a function means that it should be replaced or do the works in here. So if you replace, the box will be stayed here. So still this y and this y will not be same. And in this case, you haven't declared the y. So in most programming language, you will get a compilation error. So here I have a z equals to 300. Since we are in the same block, if you think, but still, since we are calling a function, again, function inside a function will create new blocks. This is another concept that I haven't told. So this z and this z will not be declared. So there is no z declared because it's a separate block and this is a separate block, even though that function is calling from this block, but it will make a different sense. So z will not be declared here, so you will again have a compilation error. So let's say we have two functions again, and this time we have a parameter called int x. So if we again declare x equals to 50, and these x and these x are also different things. You could also pass this x here, but again when you pass, it's really copied, but these x and these x are two different things. It's simple as that. If you are suffering again, mail me, I will give you more details. But for simplicity, understand that these x and these x are two different things. And the z will have a compilation error, which came from the previous slide mistakenly. So let's say we have a for loop block, and the entire for loop is actually a block of code. So whatever you write, this switch also a block of code. So no matter how many cases you have, so whatever variable you declare will be available inside that switch statement. So this if also a block of code. So whatever variables you declared will be available inside this block. So this x will be available in this entire block of code. So let's say if I want to declare again x, I will have a compilation error because x is already declared inside that block. So if we try to change the variable x, it will be correct. If I try to declare a variable called new var and give a value 10, let's say, and if I try to change the variable inside that block of code, I can because it's nested inside. And if I try to change the x from this outside block, I can. But if I try to change the new var, since new var is available inside this block, so it will not be available outside, so we'll have a compilation error. So if you understand this concept, 70% of the programming is done. Newbies suffer for this months. So nesting, we already have seen nesting. So nesting is possible at any depth as you want. So it could have a function, and inside a function you could do something with statements or call a function, and inside that you could also have a loop. Inside that you could have some statements, or you could have another loop inside the loop, and then you could have another if condition or call another function and so on. So assume that these all are closed or end. But here we will not have this space, so I haven't shown it, but you have to end all of the while loops, if loops, and for loops, and the last if condition. If you don't, you will have a syntax problem. So data types. We're going to talk about common data types across all programming languages. So numbers, there are a few types of numbers. One is called bit. Bit is also known as the Boolean, which also represent the 0 and 1, which we have seen in first, the machine code. So machine codes are actually represent with the bit. And we have byte. Byte is actually the combination of bit. So 1 byte means you have 8-bit characters, 8-bit numbers, and integers are int represents integers. You cannot have a fraction of numbers in integer data type. And you could have long. Long means the big integers. You could have more or double than what can an integer hold. And you will have float. Float has the data limit as integer, but it could also hold fraction numbers or decimal numbers. And you have you can also have a data type called double, which is bigger than float, and another data type called decimal, which is bigger than double data type, so which is also decimal. So you can have these type of data types in almost all programming language, but some of those might not have the byte, bit, or the decimal data type. So if we represent it by the boxes, so for integers we have byte, short, int, long. For decimal we have float, double, decimal. So small to big. So binary is really smaller than integers. Integers are smaller than decimal, but some of those have the same bit size. So, but in theoretical concept, so you can have many precision point in decimal, but you can't have that in integers. So small to big. So first, above ones are the smallest, and below ones the bigger. You can remember that. And let's see the data types in depth, that how computers understand. I tried to stay out of this, but again, I tried, but turns out that these really impact a programmer very uh, depthly, and give them the idea that what should they do to optimize memory. So a bit could also be known as bool or boolean. So it really varies from uh, language to language. So it really represents 0 and 1 bit, and a byte is represented by 8 bits. So what we have said earlier. So it means that you have a combination of 8 zeros or 1. So you have 8 empty places for 0 and 1. And you could really represent these 0 and 1s with that binary number. So binary numbers are represented like this: 2 to the power 1, 2 to the power 2, and 2 to the power so on. So each place the 2 to the power will be changed, and the number values will be changed. So if you have 1001, it means 8 is true and 1 is true. It means they both add and give you the value of 9. So with the 1-bit data type, you could save up to 255, as I can remember. Yeah, 255 value, 0 to 255. So if I say 101, it means the 5, because this one and this one is only true, this one and this one. So if I say 1001, so that means 128 plus 1, 129. So byte is also known as tiny int, so it really depends on what programming language or what database you are using. The data type varies, but they mean the same thing that we have discussed earlier. A character is 1 byte, as we have shown earlier. It also carries 0 to 255 value. So a character actually represents A, B, C, D, etc. So under the hood, it's actually number. It represents 0 to 255 numbers. So each number have a character assigned to it. So whatever you see in a computer is actually the number, and it's processed by machine code, as we have declared in the previous slides. So string or varchar is known as a fixed length character or immutable. So if you take 4 characters, hello, so it will be 4 into 8 bits. So since one character takes 1 byte or 8 bits, so 32 bits. So if you have 5 characters, it will be 5 into 8. So something like that. You will have a brief idea that what characters are. So strings are. So int is in most programming language, it's 4 bytes modern days, but in old days it was 2 bytes. So it really depends. You could read the manual that what size it is. So depending on the size, bytes, you will have the bits. So 1 byte gives 8 bits. So here's 4. So 4 into 8. So we have 32 bits. So whatever bit you have, you could have the maximum number by 2 to the power 2 to the power bits minus 1, and then minus 1, something like that. So you'll have the maximum value, what can be represented by these bits. So again, we have big int, or also known as long, or long for some programming language, or some programming language say int64. So all are same thing. So which represents by 8 bytes. You can have a very huge number, which is really larger than 2, which can really hold 60% of the atoms inside the C, so which is a really huge number. So again, we have GUID. So if you can handle a number with long, or if you are using a database and having auto-incremented keys, and if you think that you will run out of long data type or int64 data type, you could use GUID. So GUID is represented to have the unique number across time and space. So once a GUID is generated, it will never be same again. So that's why it said that it will be unique across time and space. So once a GUID is generated, it will be never same. So it only takes 16 bytes, which is very efficient. So 128 bits. So in very small number, you will have a very efficient result. So it's also known as unique identifier for databases, or some databases UUID. It's really useful for database handling. And when we talk about databases, it will be helpful. That's it. So strings, it's actually represented by characters. So list of characters are really series of the series of characters to represent text. That's it. So string is more elegant way of saying that it's text, and varchar is a synonym of string. And this is a very interesting concept for newbies. They really suffer for this. So if we have a character data type, and if you have a string data type, see that a character could hold one character only, but a string could hold more than one character. So that's the concept. And again, see the quotations. String have double quotes and characters have one quote. So some programming language doesn't care what code you give, but most programming language, they do care. So this is the difference between character and string. String have double quote, character has single quote. That's it. So void, you will encounter the data type void. Void means it really doesn't return anything, or you are not sure about the data type. That's it. So if you have a function, void function, that means it doesn't return anything. But if you have a function, int function, that means it returns a data type which is in integer format. That's it. So array is another interesting data type concept, and whatever list you can think of in a computer, it is either array or linked list. We're going to cover both of those, but not linked list in depth, but we'll give you an idea. So you might think of array as a list. That's it. So let's say you have a to-do list and you want to represent it in array or in programming, so you have to use an array. So there is no other way to deal with it. So arrays are zero-based index, and most programming language, most of the lists you get are really zero-based index. That means they start from 0. That's it. In human context, we really start counting from 1, but in programming, most of the time you're going to encounter from 0. So it's a zero-based index. That's the first thing about the array, and it's fixed length. So first, if I say that 8 items in the array, so it will be fixed. You cannot change it later. So that's another concept for the array. So you can change the item values anytime. You could change the to do item 2 to do 3, maybe something like that, anywhere. Accessing an array is very fast. You could access any item in constant time. So these 4 parts are true for all programming languages, but last 2 parts are true for these red-headed programming languages. So some same type of array contains same type of data, but it is not true for all programming language. So you can't add or remove an item anywhere in the array. So it is also true for this programming language because JavaScript handles arrays differently. So you don't have to know more about this. You have to, if you know this far, you are good enough. And let's take an example that how we can change item in an array. So if we say that int numbers 4, it means the programming language will give you a new array or list of 4 items. That's it. So maybe at first the items will be null or no values at all. So let's say that we have defined the values. Since it's a zero-based index, let's, as you can see that it's starting from 0 and stopped at 3. Again, we ask for numbers 4. It gives 4 items, but the last index number is 3. You have to understand that. So let's say we want to access index 2 and index 3 in the list item. So index 2 will be index 2 will be this one, is index 2. So in human context, this is the item number 3. So we're accessing index 2, which is a third item in the list. So I misspelled. Sorry for my mistake. So if I say index number 2, it means the number will have the value of third item in the list. So whatever you say, it is actually +1 in the list. That's simple. So if we want to print it, we just say print number. It really depends on your programming language that what is the print command, and it will print 22 in this case. So if we try to change any item, any index value, so if we say index 1, numbers, square bracket 1 equals 33, it will be changed. So previously it was 2. So when I say that, it's really raised to 33. That's simple. It's really very fast. So some of the problems we have in the array, like it's really fixed length. If we want to add a new item, we have to create again a new array list and copy each item from one array to another. So which is a very complicated thing and very slow thing. So linked list solve those problems. It's really memory based. It's dynamic. It's very fast, and it's really advanced topic. We're not going to go through it, but we'll give you some examples that pros and cons. Adding item after or before another item is really very fast, and removing any item from after or one another is really very fast. But in array, if you want to remove one item, you also have to create the whole array again. Searching, same as array. Sorting, same as array. Dynamic memory collection, so slow. Why it is slow? So retrieving each item in array is very fast. You can do it in constant time, but it really have to go through the whole items in series. So if you have n items, and if you want to get the 5th item in array, it will get in a constant time. It will take just a second. But for linked list, you have to go through first 5 items to get to the 5th item. So that's it. So could make memory leaks, which is a very complex topic. We're not going to talk about it. Just if you know, that's fine for now. So comments are most important thing for the programmers, and newbies tend to escape it. I did it when I learned it, why write programs. But again, when you program for months, let's say 1 or 2 months, you'll see that some of the things that you have write previously, you couldn't understand. You have to go through the codes again. But if you just write the comments, you just understand that what you did earlier. Comments does not compile and does not take part of, does not part in any action in your program. It's just for the developer's convenience, and you should write it. And for the comments, you just Google for your programming language syntax. That's it. So developing, I have 8 rules for developing. So first, rule 1, love what you do. So if you're not happy what you're doing, change it. And if it pleases you, keep doing it. That's it. So rule 2 is don't give up. So first rule says that love what you do. So again, so you think that programming is fun and you get in programming, you loved it, and then after some time you just couldn't handle it. Then you give up. You don't. First you loved it, so stay with it. So that's the concept. But when you start it, you don't like it, just escape it. Don't bother doing it. So that's the concept. So when you're doing something, don't give up easily. So rule 3, failing is just fine. Even with a 100% failing rate, just move on. But make sure you learn from your mistakes. If you don't learn from your mistakes, you're not gaining anything. So your failing is wrong. So rule 4, keep it simple. You can do it, doesn't mean you should. So it's a complex example. So as you can see that it's a Swiss knife. It's given all the knives, but it's really hard to use. They can, so they use all the examples of knives inside one toolbox, but it's really hard to use it. So you can maybe give 10 features to the user, but it really doesn't mean that you should. You have to analyze the circumstances that what should you give to the users, and then you give it to them. So you can doesn't mean you should. You have to remember that it's a very important rule. So rule 5 says use the best practices. So we haven't done best practices yet, but we'll do it in later sessions. So it means there are some good patterns and object-oriented programming concept, and there are some frameworks to understand. Use those. Don't just try to build up everything of your own. It's really good to understand and learn for newbies, but don't use it in development perspective. Development and learning do different things. And use tooling as much as you can. I have seen many developers that who tries to be a good programmer don't use tooling. Use tooling will save your time. Whatever you're doing in 3 hours, a tooling could do it in 5 minutes. But use the tooling after having knowledge. Okay, so all the tools are really very helpful. If you're programming without IDE, you maybe using Notepad or any other text editor, use IDE. It will make your development much more faster. So whatever I'm saying, it's really for development rules. It's not really for SEM rules or learning rules. So it only applies when you develop something, which we'll get to in later sessions. So rule 7, try to be as lazy as possible. Look for easy wins. In my whole life, I was really the laziest person that any of my friends ever know. So, but I turned out to be a good programmer. So I will give you some example, but I want to show you one meme picture, so which you may have seen in Facebook. So it's really taken from Facebook. I really don't have the link. So the link says that the image says that Bill Gates is saying that I will always choose a lazy person to do a difficult job because he will find an easy way to do it. And some random guy who is very lazy calling Microsoft to hire him, something like that. But the concept is wrong. Try to be as lazy as possible is a different concept. It's not like not doing anything at all. So to demonstrate it, I have to give you an example. Many of you are going to encounter PHP, and I was hired by a company around 2011 or maybe 10. So I was doing a PHP job. I was a newbie at this point at PHP. So I was sitting there and watching people writing and converting HTML to PHP. It's like writing the same line over and over again. They're just copy pasting and using the quotation marks and PHP echo to print out those syntaxes. So let me give you an example in Notepad. So HTML is something like this. So div code, maybe hello world. In PHP, what they are doing is something like this. Equal div, and copying all the things. I just do it once and get bored. I didn't do it any more than that. So what I did is I just sit there and relax for an hour, and then I just open my favorite programming language and write a program. So let me give you an example of that program. So here is the program that I wrote. I wrote it in 2 hours, and it's not a enterprise level application, but it really does what it need to be uh, doing. So let's say I have an HTML input and I really want to see it in PHP. So I just, where should I click? Convert to PHP, that's it. Uh, okay, so convert to PHP. Yeah, that's it. So here I'm using array, but it's not really very efficient, but we could change it by settings, but it's the default settings. I haven't used it for months. So whatever inputs you give, if you have 10 or 20 lines of HTML, just press it. It will convert the PHP HTML to PHP in a second. So after that, I haven't write any PHP echoes anymore. So again, I have seen that they tend to change some of the keywords from HTML. So again, I have used another option called finding and replacing. Let's say I want to replace world and world with maybe hello 2, and sorry, my PHP variable maybe bh, let's say, example, and it is going to be hello 2. So is it case sensitive? Let's say it is, and set the values, and if we convert again, as you can see that this time we're going to have a bh variable which is taking a value for hello 2, and whenever we have a world inside the HTML, it is really replacing the PHP syntax. So it's really very efficient. I did it in 2 hours and they're doing it for months. So this is the lazy thing. So find the easy win so that you don't have to do the same thing again and again. You have to understand the laziness. It's not like doing nothing. You have to find a way where you do a thing once, but really gently, and really hard work, but did it once. That's it. You never have to do it again. Just do it and the program will do the rest. That's the laziness. Look for the easy wins. So rule number 8, it really breaks all the rules. So try to make things happen no matter how. So in maybe rule 5, 6, we have tell that you should follow the best practices, use IDEs. But when you are in a competition or you have a time frame for projects to submit, the first thing is try to make your thing work. That's the first rule should we have. But again, if you don't love it, there is no need to go through these other rules. So again, the first thing you should do is make things happen. So when the thing is correctly happening, then you could optimize it, use the best practices, and when you learn using the tooling, you should use the tooling. It really makes your work so much faster. So programmer's first language, it's really up to you. So whatever you choose, you must stick with it for 2 to 3 years, as I've said in first topics. So for in our future sessions, we're going to take the JavaScript as our first programming language, but whatever we show will equally applicable in other programming languages, and syntaxes are also same like C or C++, but JavaScript is one of the language which does the job differently than any other language. And knowing JavaScript is the power, because if you want to talk with millions of people, there is no way to talk with them with C or C++ or maybe in other language. JavaScript is the only language that the compiler is available to all the users in the world. And it's the most accepted, widely accepted programming language. Again, our first language will be JavaScript, and after that, we will be move on to other languages like C, C Sharp, or maybe Java, so on. So we're going to do JavaScript plus jQuery, and we are going to go deep into it. So problem with this JavaScript or modern languages, easier developmental languages that newbies really enjoy, but they learn first, don't give up. But downside is they don't like to learn core programming. So this is a downside, but we could remove it by your enthusiasm. So stick to easy methods. They don't try to have something complicated if that comes to their life. Uh, try to analyze less. So these are the problems that I have encountered with newbies. So conclusion, stay tuned for our next session. Join our group. And thank you. I'm Alim Kareem. You could reach me at alim.kareem.necu@gmail.com. You could Google me. I have a blog. And you could find our developers organism by fb.com/developers organism or developers-organism, or mail us info@developers organism. Special thanks to Dr. Nova Ahmed. Uh, she was really very helpful, and she encouraged me to do this. Without her, maybe this session wouldn't have happened. So all thanks goes to her, and thanks to North South University for giving me this opportunity. And thank you.